Hi everyone, and welcome to this video on probably one of my most favorite topics of life. And I know that's sad to admit on camera, but anyway, it's partial fractions. Now, yeah, if you have no idea what I'm talking about, well, hopefully you will shortly, because I'm going to go through something that is just amazing and is used time and time again in VCAA exams. Now, if you don't know what VCAA is, don't worry about it. Partial fractions is universal. Now, my name's Darren from Maths Guru. Thanks very much for watching this video. Hopefully it's going to be useful. If it is, if you can do me a massive favor and subscribe to my YouTube channel and click like on this video, that would be immense. Nobody watches math videos. You're probably only watching it because you've got to. And I get very little feedback about whether this is any good or not. So your help would be greatly appreciated. Now, behind me, we see our learning objectives. Understand how to split up an integral into parts. Why would I want to do that? Understand how to use the CAS. Why would I want to do? No, we know why we want to do that one. I know. Understand when to use each of the methods: distinct linear factors, improper fractions, repeated linear factor, and irreducible quadratic factor. Now, hopefully by the end, I will have covered all of that stuff. Now, basically, I remember doing this at school, and then really bearing in mind I did A-level maths. It was one of the things that, again, I could just do this, and integration by substitution and a few other things were just like, okay, this makes sense. I can see why I'm doing this, right? Now, it's going to build on all the differentiation and integration we have done prior. And if you haven't watched those videos, again, they're there for you on mathsguru.com to try, hopefully, to, get you up to speed. But whenever you're doing any of these questions, you've got to realize that what I'm teaching you is the theory, right? That's the point. I'm trying to teach you the theory on how this works. You have to do as many questions as you possibly can and trip over and trip over and trip over again and seek help from as many people as you can, because then you're going to understand the nuance and you're going to actually be able to apply it to SAC questions, like application style questions, which are there to try and confuse you. But if you're not confused because you're like, well, hold on a moment, I know what that's asking, life is really, really good. Now, we're going to recap a little bit of year 7 maths, and probably even earlier, the idea of proper and improper fractions. All right. Now, a proper fraction is basically one where, the numerator is effectively smaller than the denominator. And to go back to sort of basics, that's like a half. That's a proper fraction. Where the numerator is bigger, that's an improper fraction. Now, again, wouldn't it be lovely if we dealt with things like a half and 3 on 2? But we don't in special maths for some reason. We deal with now polynomials. And again, the same idea is true for a polynomial. A proper fraction will have the degree of the numerator being smaller than the degree of the denominator. And if you're wondering what that g of x and h of x is, I'm basically just saying if a fraction, a rational function or a fraction has that form, g of x on h of x, an improper fraction will be the other way around, where the degree of the polynomial on the numerator will be bigger than that on the denominator. Now, we don't really want it to be a situation where that is true. And this whole idea here now of partial fractions is how can we split things up? If I had, for example, I don't know, x squared plus 2 on x minus 3, how can I split that up into two distinct fractions that will then help me to, well, actually integrate it? And the whole point of this is to give you a tool to do just that, to split things up and integrate it. Now, the good things is with this particular topic, there are rules. You'd imagine that would be true of all of maths, really, wouldn't you? But there are rules for this, yeah? So I put them in here. Thanks so much to Cambridge for allowing me to use your textbook and your examples and snippets from the theory. You guys absolutely rock, and hopefully I'm doing you all proud with the stuff I'm putting out there. Now, there are 4 things to look for. The first is you're looking for linear factors of the form ax plus b in the denominator. Now, for every one of those linear factors, there is going to be a partial fraction in this form here. Now, again, my advice is put this in your summary book or practice and practice it to death so that it gets into your head. For every repeated linear factor of the form ax plus b all squared, there will be partial fractions of the form a on ax plus b and b on ax plus b squared. Now, again, this isn't going to mean too much for you if you haven't met partial fractions before, but it will do later. For every irreducible quadratic factor of ax squared plus bx plus c in the denominator, there'll be a partial fraction of that form. Now, irreducible basically means I can't separate this into 2 linear factors, right? So if it's irreducible, I won't be able to factorize it into 2 linear factors. And for every repeated irreducible quadratic factor of this